first PVM is freebies from 6 tanks. Hey, thanks sir.
Chapter 1. Initial Inspection.
The Sony badge is missing, so we're gonna have to find one. This only has line A and line B buttons. Learn about NEP, the former owners of this monitor and huge broadcast and media company here. Get one crack here. And some more damage over here. And funny kind gap on this corner. What? No RGB. One hairline crack right here. Somebody would write PVM-14n5u on the back. This is how a real PVM-14n5u label look. And this is how one 14n1u look, which was probably originally on this back panel. So is this a 14n1u or a 14n5u? The N1 or N2U uses the older S2 chassis, while the N5 and N6U uses the newer S2A chassis. The N2 and N6 has RGB inputs, while the N1 and N5 has no RGB inputs. So this has to be an N1 or N5. The N1 has a VDP chroma chip, while the N5 has a CXA chroma chip.
Chapter 2. Internal Inspection.
N1 or N5, we ain't gonna know until we see the chroma chip. The CXA 2060 BS chroma chip confirms PVM-14n5u internals and a 14n1u or 14n2u for the back cover. Gonna have to redo this repair. Just documenting the routing of the cables for reference for reassembly.
Chapter 3. Teardown.
These are ground wires. The green one specifically connects directly to mains ground. Make sure to press the release tab for these locking safety spades. Otherwise, you can pull the connector from the IEC socket right out.
Chapter 4, Plastics Repair.
I wonder if this is factory soldering. These are the guides for the screw mount. Confirm there's a lot of space for the cement to clear for the broken mount. The guide tabs are broken off on this side, so laying on the ABS cement thick will not be an issue. These PS markings on the plastic confirms polystyrene is used. ABS has styrene, so we can use ABS cement. Acetone melts styrene and thins ABS cement. Lego is made from ABS. This piece was cemented off camera. It has a small cement contact area, so it'll need to be reinforced. You can use the cement to add material for even more strength. The cement is rigid but not brittle and not prone to shock. The Lego that was just shown reinforces this long crack. Both of the corner left side tube mounts sheared right off. The previous repair's positioning was off by quite a bit. These broken brackets help position and brace the tube. The top part of the bezel is badly bowed. Yup, more Lego. The ABS cement was built up over several days and is roughly 3 to 5 millimeters thick. I also rebuilt the tabs that hold up the metal cover so it doesn't sag.
Chapter 5, Panel Modification.
This is the location of the RGB button. The RGB button from the inside. The cut RGB button.
Chapter 6, Metal Cover Repair.
The front lip is bent. And the top is bowed. The JB weld was just applied and needs to be weighed down by weights while it cures. I'm using 3 16-inch key stock from Home Depot.
Chapter 7, Shield Refurbish.
Is the electrical tape factory or added? Let me know in the comments. The neoprene tape is dry, brittle, and flaking. Gonna have to be replaced. Cut a 3/4 inch strip off the edge of the 3-inch tape. Then cut to 2.5 inches long for the corner pieces. I used the remaining 2.25 inch wide tape for the degaussing strip.
Chapter 8, Partial Rebuild.
Does the speaker go in this way? Or does it go this way? When in question which way parts install, you can find out by looking for screw head marks, like damage or color differences where the screw head made contact. So far, everything is fitting together nicely. And the ABS cement is holding up the tube like a champ.
Chapter 9, A-board repairs.
This is a previous repair for CN651, which is a ground tab. Desoldering has revealed the pad has peeled off the board. I used a header pin to bridge and stabilize the ground tab. I simplified the wire routing to a better ground point on the same ground plane. The ground plane here where the board contacts the frame is heavily corroded. So I made a simple bridge. By the way, there's a conformal coat on all the PCB's trace side. It's used to seal the board from moisture and dust. You can find conformal coatings on Amazon, from spray to brush applicators.
Chapter 10, A-board RGB modified.
The 14n5u does not have the RGB input and the 16:9 aspect ratio that the 14n6u has, but Sony's service manual tells you what components are missing from or are on the various 14n boards. I've marked the PDF with the missing components on the 14n5u that are on the 14n6u. You can add components to enable RGB and 16:9 or add buffers to the video input on the 14n5u. You can find a marked PDF link in the description below. Again, in the service manual, Sony specifies what components are on the 14n6u that are not on the 14n5u. I've marked them in blue, and this is for the A board. All surface mount chip components are 2012 or 0805 sized. C006 is a 0.01 microfarad 50 volt capacitor and is used to prevent bounce when the RGB button on the front panel is pressed. C310 to 312 are 0.1 microfarad 25 volt capacitors and are used to filter DC noise from the RGB lines. CN403 is a plug connector header and is used to connect the RGB lines from the A board to the Q board. R030 is a 10 ohm quarter watt resistor and is used to enable RGB and 16:9. S006 is a tactile switch and is used to switch to RGB input. Here's the tactile switch and bounce capacitor installed. The following are hole spacing for the tactile switch. The replacement tactile switch is a Panasonic EVQ-PC405K and has a slightly longer actuator than the original. Otherwise, both dimensions are similar. Tactile switches with this combination of pin spacing and actuator length are becoming exceedingly rare. The EVQ PC line come in a variety of operating force. These are the RGB video DC filters installed. There's only a 5mm hole spacing for R030. Nice of Sony to point out on the silkscreen that line B is enabled by R032, which is already enabled because of the installed resistor, and that RGB is enabled by R030. Because of the 5mm hole spacing, R030 needs to be a compact 3mm length. Do continuity test or component measurements through the soldered joint to confirm your soldered joint and trace integrity. Saves you a lot of headaches down the line. I installed common header pins at CN403, but the pitch is actually 2.5mm. To make things harder on myself, I decided to replace all the tactile switches. Nah, it's actually because of the slightly longer actuators of the Panasonic that does not slip like the stock ones. It's actually because of a bad design by Sony. The push buttons on the front panel only catches the uppermost part of the stock switch's actuator. Serious question. Are you Team Pomona or Team Easy Hook? Let me know in the comments. With all the switches installed, now just to make sure they are working and soldered on properly. To do this, I just connect one lead to any ground point. The other lead goes to these points where the trace from the switch leads to. This way you are confirming the integrity of the component as well as your soldered joint. Yes sir, cleaned and ready to go back into the chassis. Quick test with RGB connected directly to the A board and it's working nicely. What's not working nicely is the audio, which sounds distorted when it's unbuffered.
Chapter 11, Keyboard Panel Modified.
The original BNC connectors are 50 ohm. Notice the difference in the dielectric between the 50 and 75 ohm connector. There was a previous repair to the BNC jack on the right. The leg broke close to the base, so some dielectric was removed to expose what's left of the leg. Compare the jack to the intact BNC jack on the left. Curiously, the video output BNC jack is different from the other two. This metal bracket is connected directly to mains ground. Rusty. Not rusty. I filed the panel to create D-shaped holes to accommodate the D-shaped Amphenol panel mount BNC connectors. These Atomtech BNC jacks need no modification and fit directly into the stock hole. The Amphenol jack is 75 ohms and the Atomtech is 50 ohms. To reach the through hole, a leg needs to be added to the panel mount BNC jacks. I use the 75 ohm Amphenol jacks for the RGB inputs, while the 50 ohm Atomtech BNC jacks were used for the composite inputs. This whole metal bracket is ground. I hot glued the audio and remote RCA jacks to ensure they do not loosen as they are not keyed. The metal body and ground pins on the BNC jacks are already secured to the huge ground bracket, so you don't have to solder them. It's a redundancy. Make sure to reuse the old ground tabs from the original composite BNC jacks.
Chapter 12, Keyboard Calculate.
Again, Sony provides in the service manual the information of the missing components from the N5U that is on the N6U. I've left notes and color-coded portions of the service manual to show what they are and where the various components go on the cue board. Clipped and notated PDF service manual files as well as high-res board pictures are provided in a linked file in the description. Make sure to read these important notations for the various components. The NPN transistors for the RGB and sync circuits use an ECB leg layout. Note that Sony lists several part numbers for the semiconductor components. All of these are discontinued, so you have to search eBay if you wish to use the original parts. The PNP transistor for audio uses the ECB leg layout. The diodes are all the same except for the one Zener diode for the sync circuit. Again, you can download a linked file for these pictures that show what components you need and where they go. If you are sourcing your SMD parts, make sure again they are 2012 sized. Here's a view of the through-hole components as if you were looking through the board. A view of the through-hole components with a flipped view. Now a proper view of the installed through-hole components. The anode on the diode is marked by a stripe and goes to the hole the arrow is pointing to. Look for the plus symbols for the electrolytic capacitors. Emitter collector base is clearly marked on the board for the transistors. I bought one of these cheap testers to double check the transistor's leg layout and type and to make sure it's working. Finally, here it is, the fully populated Q board. Populating the Q board adds voltage buffers to the RGB-S and RGB audio lines. The buffers isolate the connected source from the monitor. Voltage from the console to the PVM will be the same, but current to the PVM will be provided by this buffer. Besides protection, what are the benefits for analog video, since video equipment are made to be impedance matched? Make sure to let me know in the comments. You'll need to use a big tip for soldering on the ground plane. This is the repair for the previous damage to the line B composite input. Looking back at the old repair, the center pad for the line B composite input was already gone. I installed right angle headers for CN1303.
Chapter 13, Initial Test.
Not gonna lie, always have butterflies before pressing the power button. Bang! This looks sad without its badge. eBay tang.
Chapter 14. Sony Badge Replace.
Got these from Facebook Marketplace for $5. Just need to scrape the locking cement from the tabs.
Chapter 15. Cable Fabrication.
You know what, I changed my mind. Let's put in some better connectors than these DuPonts. One option is to go with JST X8 connectors, which has this locking clip. Another option is to go with JST EH connectors, whose headers are similar to some of the ones on the A board. If some of the JST EH parts are unavailable, you can use the Adamtech 25SH line as replacements. The JST EH connector fits some of the headers on the A board. This confirms 2.5mm pitch spacing for the through holes. The right angle EH header clones from Adamtech look identical to the headers on the Q board. I've decided to go with JST EH connectors. To make the wire harness, strip about 1/8 inch of insulator off of 24 gauge wire. 24 gauge wire is usually the median size for pins of these type of connectors. For my trusty Hosan P706 crimper, I use 1.7L for crimping 24 gauge conductor. For the insulation, I use 1.7H on the crimper.
Chapter 16. Service Menu Adjustment.
Check out the health bars. Horizontal centering needs adjustment. To access the service menu, while holding enter, press menu. You'll see version 3. Press enter and you'll see CXA. Press enter again and you will see 001 destination. This is the service menu. Press and hold menu while pressing the up and down buttons to cycle through the options. Option 72 is to adjust horizontal centering for 60 Hz RGB. Now just press the up or down buttons to adjust.
While holding menu, press enter to bring up save. Again, while holding down menu, press enter. A musical note confirms save. To exit service mode, press enter to go to the raster center adjust screen. Then, while holding menu, press enter.
Chapter 17. Wrap up.